Good afternoon, everyone. In this video, I'm going to explain the MLT experiment to feature selection and feature extraction. This experiment focuses on reducing the number of features in a data set using feature selection and feature extraction techniques. The data set used in this experiment is D3 Toyota feature.csv, which contains the information about the Toyota cars, including features such as age, KM, HP, weight, fuel-related features, and then price target variable. The goal of this experiment is to identify the most important features that influence the car price and reduce the experiment also demonstrates PCA, LDA, and image feature extractions. And the first one is read the data set. First, the required libraries are inputted. Pandas for data manipulation, NumPy for numerical operations, sklearn feature selection libraries. Then the data set is loaded. The program prints dataset shape. First few rows of the dataset. This helps us understand the structure and size of the dataset. And the second one is drop unnecessary columns. Two columns are removed. First one is BOBAG guarantee and then doors. These columns may not be useful for feature analysis. Dropping unnecessary features helps to simplify the dataset, improve model efficiency. And then third one is detect the columns containing outliers using IQR. Outliers are detected using the interquartile range IQR method. Formula IQR is equal to Q3 minus Q1. Lower bound is equal to Q1 minus 1.5 into IQR. Upper bound is equal to Q3 plus 1.5 into IQR. For each numerical column, Q1 and Q3 are calculated. Values outside the range are identified as outliers. Columns containing outliers are stored in outlier calls. Then those columns are dropped from the data set. This helps remove noisy features that may affect model performance. And then fourth one is identify low variance columns. Variance measures how much a feature varies. If a feature has very low variance, it means the values are almost constant and do not provide useful information. The code identifies columns where variance is less than 10. These columns are stored in low variable columns and then removed. Removing low variance features improves model learning efficiency. And then fifth one is identify features with low correlation with the target variable. The target variable is price. Correlation between input features and price is calculated. Only the absolute value of correlation is considered. If modulo of correlation is less than 0.2, then the feature has very weak relationship with price. These features are stored in low correlation columns. And then sixth one is drop low correlation features. The features identified in the previous steps are removed from the data set. This ensures that only features that significantly influence price remain. The data size after dropping columns is displayed. And the seventh one is identify highly correlated feature pairs. Next, the correlation matrix of the data set is computed. Feature pairs having correlation greater than 2.8 are considered highly correlated. Highly correlated features create multicollinearity, which can affect machine learning models. All such feature pairs are stored and printed. Example output is a feature 1, feature 2 correlation variable. And then eighth one is drop one feature from highly correlated pairs. From each correlated pair, one feature must be removed. The feature that has low correlation with the target variable price is dropped. This ensures that the dataset keeps the most informative feature. The list of dropped columns and new data cells is displayed. And the ninth one is separate input features and target feature. The data set is split into input features X. These are all features expect price. Target feature Y. Y is equal to price. This separation is necessary for machine learning models and feature selection techniques. And then 10th one is univariate feature selection using chi-square. Feature selection is performed using select k best with chi-square test. Steps include convert features to non-negative values, apply select k best, select top 10 features. Chi-square measures the dependency between each feature and the target variable. Features with high scores are considered more important. The selected features names are printed. And the selected feature name is age. And then 11th one is mutual information score. Mutual information measures the dependency between variables. It tells how much information an input feature provides about the target variable. Using mutual information regression. The code calculates a mutual information score for all input features. The features with the highest mutual information score is printed. This indicates the most influent feature for predicting price. And the 12th one is feature extraction using PCA. PCA stands for Principal Component Analysis. It is used to reduce dimensionality while preserving maximum variance. The steps performed are step 1, standardize the data. Features are standardized using X minus mean by standard deviation. This ensures that all features have equal scale. And then step 2 is compute covariance matrix. The covariance matrix shows the relationship between features. And then step 3 is eigen decomposition. Eigenvalues and eigenvectors are calculated. Eigenvectors means principal directions, and then eigenvalues means importance of those directions. And the step 4 is sort eigenvectors. Eigenvectors are sorted in descending order of eigenvalues. This helps identify most important principal components. And the step 5 is project data onto principal components. The data set is projected onto the first two principal components, PC1 and PC2. These two components represent the maximum variance of the data. And the 13th one is feature extraction using LDA. LDA stands for Linear Discriminant Analysis. Unlike PCA, LDA focuses on maximizing class separation. Since LDA requires categorical targets, the price variable is converted into two classes using quantiles. Then, linear discriminant analysis is applied to extract LDA1 and LDA2. These components help separate classes effectively. And the 14th one is image feature extraction. Finally, a simple feature extraction is performed on an image. The image lena.png is loaded using PIL library. Steps performed include step 1 is read image. The image is read and converted to RGB format. Step 2 is display image. The image is displayed using matplotlib. Step 3 is convert image to array. The image is converted to a NumPy array. And the step 4 is extract the pixel features. The program calculates the mean value of each RGB channel, R mean, G mean, and then D mean. These values represents the average intensity of red, green, and blue channels in the image. This demonstrates basic image feature extraction. Finally, in this experiment, we performed Feature selection using variance, correlation, and chi-square test. Feature importance analysis using mutual information. Feature extraction using PCA and LDA. Image feature extraction using RGB mean values. These techniques helps reduce dimensionality, improve model performance, and extract meaningful information from data. That's all. Thank you.